Hello, boys and girls. Let's take a look at the second part of the study guide. The focus will be multiplying and dividing scientific notation numbers, as well as some word problems. Let's begin. Okay, boys and girls, let's turn to the third page, part 4, multiplying scientific notation. Now, whether you're multiplying or dividing scientific notation, you have to combine like terms. So let's first focus on the coefficient. Here I have 3 and 3/10 times 10 to the 0 power times 1 and 2/10 times 10 to the third power. Well, my coefficients, I have 3.3 and 1.2. I'm going to multiply that right here. I'm going to 3.3 times 1.2. 2 times 3 is 6. 2 times 3 is 6. Put a 0 as a placeholder. 1 times 3 is 3. 1 times 3 is 3. We add this up. We get 6, 9, 3. And I have 2 decimal places in my problem, so I should have 2 in my answer. So it is 3 and 96 hundredths. That's the product of my 2 coefficients being multiplied by each other, and then I multiply my base 10 numbers together, and 10 to the 0 power times 10 to the third power is simply 10 to the 0 plus 3 power, or I'll rewrite the whole problem, 10 to the third power. And that is in scientific notation. The coefficient is greater than 1 and less than 10. It falls in the proper range. And I have it multiplied by a power 10 number. Let's take a look at our next problem. Over here I have 1 and 1/100th times 10 to the negative third power times 9 and 0/10 times 10 to the 8th power. We'll multiply our coefficients together first, and I have 1 and 1/100th times 9, which will be 909 with 2 decimal places, so it's 9 and 9/100ths times, here we got our base 10 numbers, we multiply 10 to the negative third times 10 to the 8th, and that's simply 10 to the negative third plus 8, and that'll be, that is 9 and 9/100ths times 10 to the 5th power, because a negative 3 plus an 8 is 5. And that is also in scientific notation, so I don't have any conversions to make. And that'll be it for the first 2. And this is the last multiplication problem that we have. We have 4 times 10 to the 0 power times 5 and 2/10 times 10 to the second power. We multiply coefficients first, and this is going to be 4 times 2 is 8, and 4 times 5 is 20. And I have 1 decimal point in my problem, so I have 1 in my answer, 1 in my product. And then I multiply my base 10 numbers. I have 10 to the 0 power times 10 to the second power, which is really 10 to the 0 plus 2 power, which gives us a grand total of 10 to the second power. This is not in scientific notation, so I need to kick this over 1, because my coefficient has to be between 1 and 10. Now, if I move the decimal point over 1 to the left here to get down here, that means just to get back to my base number that I have here, I have to move it over 1 plus the 2 more times, so that would be 10 to the third power. And just so you understand what's going on here, 20 to 20.8 times 10 to the second power would really be, I just would bump this decimal point over 2 places, which would give me 2080, which is 2,800. And in order to get the same thing over here, if I had a base of 2 and 8/100ths, I would have to kick this over 1, 2, 3 times, okay, which is 10 to the third power, which would give me 2080 as well, 2080. Okay, and This is my final answer in scientific notation. Now let's do some division. Go to part 5, dividing scientific notation. Just like multiplying, we are going to combine like terms. We can divide our coefficients, and then we can divide our base 10 numbers. And 21 and 3/10 divided by 7 and 1/10. Well, let's bump this over, and I'm going to guesstimate that I could probably, 71 will not go into 21. I'm going to guess it's going to go into 3 times. 3 times 1 is 3. 3 times 7 is 21. That was a good guess. So my answer is 3. When I take 21 and 3/10 and divide it by 7 and 1/10, I get the answer of 3. And when I take 10 to the 9th power and divide it by 10 to the 5th power, that's really 10 to the 9 minus 5 power. Just find the law of exponents says find the difference between our exponents. So that would be 4, 10 to the 4th power. And that is written in scientific notation. And we are done. Let's take a look at the next one. Here I have 9 times 10 to the 14th power divided by 3 times 10 to the 3rd power. This will be easy enough. 9 divided by 3 is 3. And 10 to the 14th power divided by 10 to the 3rd power is going to be 10 to the 11th power, because 14 minus 3 is 11. And this is also in scientific notation. And I am done with those 2 problems. Let's keep on rolling here. We've got some more dividing problems to do. We're dividing scientific notation. These are the last 2 problems of section 5. We're going to divide the coefficients first, and then we will divide the power 10 numbers. So we're just combining like terms. 2 and 1/10 divided by 7, I can tell you right now it's going to be 3/10 times 10 to the negative 4th power divided by 10 to the negative 7th power, which this is really going to be, I have to subtract, it's going to be a negative 4 minus a negative 7, which is really a negative 4 plus 7, which is going to be a positive 3. So it's 10 to the 3rd power. Now this is not in scientific notation. If I want to make it scientific notation, I need to take this coefficient and change it to 3.0. You could just have 3 if you wanted to, but I had to bump the decimal point over 1. And if I bump once again, look at what's going on here. This is 3 times 10 to the 3rd power. That means I'm going to move this decimal point 1, 2, 3 places over. And this is the correct answer. And that would give me 300. In order to make this 300, I just need to bump it over. I already bumped it over 1. I need to bump the decimal point 2 more places over to the right to get an equivalency. And that is my answer. Let's take a look at the next one. I have 6 and 6/10 times 10 to the 10th power divided by the 1 and 2/10 times 10 to the 5th power. Again, we combine like terms and divide. 6 and 6/10 divided by 1 and 2/10. I gotta move these decimals over 1. 12 is going to go into 66. I'm going to say, I think it's going to be 5 times. Let's see what happens here. That's going to be 60. 5 times 12 is 60. I subtract, I get 6. I bring a 0 down. So there we go. 5 times 12 is 60, and I have no remainder left. Okay, so 6 and 6/10 divided by 1 and 2/10 is 5 and 5/10 times 10 to the 10th power divided by 10 to the 5th power. We're just going to subtract here, so 10 minus 5 is 5, so it's going to be 10 to the 5th power, and that is in scientific notation. there you have it. Okay, boys and girls, let's take a look at our last two word problems from the study guide. Here we have a speck of dust in an electron microscope is 1 2/10 times 10 to the second power millimeters wide. The image is 5 times 10 to the second power times larger than the actual size. How many millimeters wide is the actual speck of dust? Well, here, let's break this down. First of all, we've got a couple different things going on here. This right here, this is the microscope image size. This is the size of the image that we see. This is the magnification of the image. That's why we can see it that large. But the actual size of the speck of dust, that's what we want to find out. So let's say if the image that we're looking at is 4 inches, okay? But we know that our microscope enlarges it twice, 2 times larger. So what would you do? You take your 4-inch image and you divide it by 2, and you know that the actual size, because it's twice as large, you divide it by the magnification, and that would give you the size of 2 inches. And that's pretty much what we're going to do here. We're going to take the image size. Okay, that's the way it's perceived. It looks like it's 1 2/10 times 10 to the second power millimeters. Okay, and we're going to divide that by the magnification. Okay, how much it's magnified, which is 5 times 10 to the second power. And when let's do our division here, we've got 1 2/10 divided by 5. 5 will not go into 1, but it will go into 12 2 times, which is 10. We subtract, we get 2. We bring a 0 down. 5 goes into 24 times. So 1 2/10 divided by 5 is 24 hundredths. Okay, we just divided like terms, and we're going to do the same thing here. And we can pretty much already figure this out, that it's going to be 10 to the 2 minus 2, or 0 power, which is really 1. Okay, now this is not in scientific notation. I need to make my coefficient between 1 and 10, which is 2.4 times 10. Now I bumped this says bump it over none, keep it put, and I bumped it over 1. So I have to actually move this decimal point one place to the left, which is a -1, that's my exponent, to get it back to its original size. So this here is the actual size of the particle. Okay, which is really 24 hundredths of a millimeter. This is the last word problem we'll do together in this study guide video. We have the SR-71 Blackbird is one of the world's fastest airplanes. It is capable of traveling at a cruising speed of Mach 3, or 3 times the speed of sound. The speed of sound is approximately 7 6/10 times 10 to the second power miles per hour. That's pretty fast. What is Mach 3 in miles per hour? Well, what I'm doing here is I'm taking the speed of sound, the speed of sound, which is 7.6 times 10 to the second power miles per hour. And I'm going to multiply that by 3, because Mach 3 would be 3 times that speed. All I really have to do is just do 3 times my coefficient here, which is going to be 3 times 6 is 18, carry the 1, and 3 times 7 is 21, plus the 1 is 22 times 10 to the second power. Is this in scientific notation? No, whoops, I gotta do that. Okay, yeah, I have 1 decimal point in my multiplication problem. I need to have 1 in my product. This is not in scientific notation. I have to bump the decimal point over 1. Okay, I've got to move it 1 to the left. Well, if I move it 1 to the left here, I've got to move it 1 to the right just to get it back, plus 2 more. So that would give me a grand total of 2 and 28 hundredths times 10 to the 3rd power miles per hour. That is moving pretty fast. As always, I hope that was helpful. And if you have any questions tomorrow, please bring them in. Remember, test is on Wednesday, and these chips are really good.